Hey guys, we're going to continue on with the same section that we were doing on last Friday. Because this is a new day, we are going to be taking new notes, so I do want you to write down the title for a second time, 1-4 Solving Equations. In our first video, we're going to focus on special cases. So when you solve an equation and the answer is not quite what you were thinking it was going to be. Here's our first example of a special case. Let's just make sure that we go through this like we were doing last week. So since there are parentheses in this problem, the first thing that I'm going to do is I'm going to distribute. So I will be distributing this 3 to the 2x and to the minus 3. And I will be distributing this 6 to the x and to the plus 1. I will not be distributing to the minus 10 since it was not inside the parentheses. Next, what I like to do, and this is not the only way to solve this problem, this is just my personal preferred method. I like to combine like terms whenever possible. For instance, and last week we were drawing our red line down the middle. If I look at this problem and I'm looking at the right-hand side, I notice that I have a set of like terms. I have two constants. I have a positive 6 and a negative 10. And so I'm going to add the 6 and the negative 10 together and make that a negative 4 instead. Now, that's not the only way to do this problem. There were several other steps. Just off the top of my head, I can think of at least like 4 other things you could have done that all would have been mathematically correct. Okay, this is just what I'm doing. Next, as we talked about last week, I like to move my variables together. So I see I have 2 letter x's. They're on different sides of the equal sign. I'd like to move those together so I only have 1 letter x. Now, in this problem, when I move my letter x, which I'm subtracting 6x from both sides, all of my x's end up canceling out. And so that's how you can tell that a problem is a special case. If all of the variables cancel out, and notice that when they cancel out, we now have like no more variables in the problem, right? It's just numbers, no more variables. So I can't even solve for x because like there's no letter x, all right? So that's how you know you have a special case. When that happens, you are not going to write down like x equals 5, x equals negative 9. Like that's not the answer. And even what I have on the screen right now, that's also not the answer. Negative 9 equals negative 4. That's not a final answer to this problem. In a special case, you're going to write down a phrase. Now, before we choose the phrase, we need to notice that negative 9 does not equal negative 4. Those are two different numbers. This is not a true statement. Since this is not a true statement, the final answer to this problem is no solution. And that's what you would write on the answer line. Now, just to clarify, no solution means that there is not a single number in the existence of the entire universe that you could plug in for x that would make this equation work. There's nothing. Not a single number out there would work. And so that's why we say there are no solutions to this problem. Last week, we got one solution. We got like x equals 2. That means if we substituted a 2 for the x, we would get a true statement. We would get an equation that works. This problem has no solutions. Now, sometimes that's the answer, right? If it says solve, you would say, sorry, I can't solve, there's no solutions. But other times, the directions might say, is this question always true? Sometimes true, or never true. So you got to read your directions carefully, try to figure out what we're asking you. In this scenario where there's no solution to this equation, we would say that it is never true. So just when you're doing your homework and when you're taking any quizzes or tests, make sure to read the directions carefully. All right, let's take a look at another special case. Very similar to the one we just did, where I'm going to start off this problem by distributing. I'm going to distribute my 3, and I'm going to distribute my 6, and I'm going to leave the minus 15 since it wasn't in a parentheses. Also, very similar to our last problem, I'm going to combine together my like terms, the 6 and the negative 15. I'm allowed to just add those together since they are both on the right-hand side of the equal sign. If they were on different sides, for instance, if I wanted to combine together the 6 with the -9, which are on different sides of the equal sign, then I would need to like minus the 6 over, or I would need to add the 9 over. And so you really need to pay attention to if they're on the same side or if they're on different sides. Again, since they're on the same side, I'm just going to straight up do what it says. 6 minus 15 is -9. And again, very similar to our last problem, I'm going to minus a 6x on each side, which will completely cancel out all of my letter x's, leaving me with nothing but numbers. That's why this one's a special case. Now, this one's a little bit different of a special case. In this problem, I get -9 equals -9. Well, that's a true statement. In fact, we learned last week that that is called the reflexive property. A number is equal to itself. So if it's a true statement, that doesn't mean there are no answers. That means there are all of the answers. All real numbers are solutions to this problem. That means you could pick any number out of thin air, you could put it where that letter X is, and it would work. It would give you a true statement. It would give you something like -9 equals -9. Any number you can think of. 5, 25, 6,273, -30.75. Like, it does not matter. You could even plug in pi, and pi would work. Every number out there is a solution. So again, if all of your variables cancel and you get a true statement, you say all real numbers. Now, just like on our last problem, this is an answer if it says solve, but if it doesn't say solve, if it's asking you, is this always true, or sometimes true or never true, then we say this is always true. It always works. Now, I know what you're thinking. You say, okay, no solution is never true. All real numbers is always true. When is it sometimes true? Well, sometimes true is for all of our normal equations. For instance, again, last week we did some problems and maybe we got like x equals 1. Okay? That's sometimes true. It's true for the number 1, and it's not true for any other number in the world. But since we got it to work for one number, we say sometimes. So if it's a normal equation with a normal regular answer that you're used to getting, that would be a sometimes true. This concludes our special cases.